So this is a question about static electricity and its uses. And to start with, it's asking about the way in which an object becomes charged. So, when a glass rod is rubbed with a woolen cloth, the rod becomes positively charged. Explain why the glass becomes positively charged. Now, you've got to remember, first of all, that whenever you're charging something by friction this way, only the electrons can move from one object to the other. So that's the first point here of the 2 marks. Electrons are transferred. Now, if you remember that electrons are negative, then in order for the glass to become positive, electrons must have moved from the glass to the cloth. Okay, they move negative electrons move away from the glass. That's going to leave an excess of protons, which will leave the glass positive. So there's the 2 marks: one for electron transfer and one for the correct direction from the cloth to the rod. Note that you got nothing for talking about positive charges moving around. Okay. And nothing for talking about negatively charged atoms. It is just the electrons that move. And then 5a part 2, a glass TV screen polished with a dry cloth on a dry day soon becomes dusty again. Explain why. Well, they weren't too fussed about which way round the charging was here. The point would be that the TV screen becomes charged. If it's made of glass and polished with the same cloth, then it will also become positively charged. But you got the mark whichever way around you put that. So long as the attraction was consistent. So if you'd said the TV was positively charged, then you would say the dust would be negatively charged. Now, you also got marks for saying that charged objects also attract neutral objects, because that is true. And that's the most likely scenario here, actually, that the dust will not really be charged, but because the TV screen is positive, it still attracts the neutral objects. Remember, it induces a charge separation on the neutral objects, which will mean there will be a very weak force of attraction between the charged TV screen and the neutral dust. Okay, so either of those two got you the marks there. Part B for question 5 is a use of static. It's the photocopier. So you just need to learn the steps. Now, even if you haven't learnt the steps, you should be able to work out some of the things in this list if you look closely enough at the gaps and what they've already filled in. And you know what the end product from the photocopier is going to be. It's going to be a copy of the thing you put in. So let's work through them step by step. Step N, a roller coated with a photoconducting material is given a charge. Now, photoconducting material is a material that becomes a conductor when light shines on it, basically. You don't need to know or understand how that works, you just need to know that photoconducting means when light shines on it, it becomes a conductor. Okay, now, looking down the list for other things, we obviously can't have L or M, they're already taken care of. So, J, a strong light is used from an image of the page to be copied onto the roller. Now that's quite a strong candidate because it seems to be near the start of the process. We're forming an image of the page on the roller. And the other thing to note, right, is that the roller is referred to in part N. Alright, so we're still at the stage in the copying process where we're talking about the roller doing something. So that's a fairly good candidate. And in fact, that's the correct answer. J goes in there. And again, light hits the roller, the charge leaks away, comes after J quite logically. Okay, because J has talked about the light being used to form an image, and O is talking about what happens when the light hits the roller. So O would have to come after J, really, no matter where you put it. And since there are only 2 gap boxes, that either means it's JO there or JO in the second 2 gaps. And JO in the second 2 gaps does not make sense. Right, so L, you see, the charge left on the roller. If it refers here to the charge left on the roller, it makes total logical sense to have the previous step talking about some charge leaving the roller. So O makes logical sense before L as well. You should look for that sort of link too. After L then, the charged areas of the roller attract particles of black toner powder. Okay, so we've got some areas of the roller still charged. The toner powder gets attracted to that. And then P, a blank piece of paper is heated and pressed against the roller. Well, that's the last stage, and that leads to the toner melting because the paper is hot and sticking to the paper, and so now we have the photocopy. So, I mean, you should learn it anyway, but even if you haven't learnt it, you should be able to work out that sequence. And then 5b part 2, well again, if you've read these descriptions, why is it important the blank piece of paper is heated? Well, it's heated so that the toner melts and sticks to the paper. They allow just to melt the toner, that's all you need to put there. Okay. You lose the mark if in any way you imply that the toner is sticking to the paper because of the heating, because of the static. The original reason that it sticks to the paper is the static charge, but obviously you can't just rely on that because that static charge will leak away. So melting the toner makes it permanently stuck to the paper after the static charge has originally stuck it to the paper.